Welcome to part 1 of Competency 2. In this video, we will work with complex numbers. In our illustration, we see some operations with complex numbers. The issue with our calculator is we have no I. So for this section, we will have to find some efficient ways to deal with complex numbers. In the box, we see the rules for complex numbers. So I is actually equal to the square root of -1, which if you put that in your calculator, you will receive an error. And let me do that for you. Okay, push second, and there's our square root, -1, push enter, domain error. That means, hey, you put something in the calculator doesn't like. This type of calculator just doesn't come with I, although if you're taking one of the other tests and you can use a TI-84, it does. So for our purposes, we have to know a few things about complex numbers. So if we square I, naturally we can use, to replace that, we can use -1. Now notice that if I is to the third power, we get -I. And if I is to the fourth power, we get 1. So there's a pattern to, rhyme to the reason. There's a pattern. So instead of focusing on our illustration above with a color coding, which you can use if you wish, that becomes a little on the complex side. I find it better just to go through the process, and I have a little bit different way to set it up. So let me show you what we can do to make this a little easier since we don't have an option on our calculator. Okay, so number 1 says simplify, and they give us 5 plus 2i times 3 plus 4i. Okay, I actually stack them and multiply in that traditional manner that we learned in school. Okay, so let me write this out for you. I have 5 plus 2i and 3 plus 2. Oh, no, sorry, 4i. Okay, here we go. 4i. Now, I multiply and make sure it's just something I do. I know it looks very juvenile, childish, elementary, but I actually write it out and I put multiply so I know what I'm doing at the time. Okay, so I will begin exactly like we do when we're in elementary school. I'll multiply the first column. And then after that, then I'll move on. Let me show you exactly what I'll do here. Okay, so I times I is I to the second power, and 4 times 2 is plus 8. Then 5 times 4i is plus 20i. Now, that's the first value, okay? You know, we do the first one, now we do the second one here. So then for the second one, oh, I've got the wrong color. Same color, that won't help us out. Let's use green. Okay, so then I will say 3 times 2i. But before we do that, we need that placeholder, just like if you were multiplying digits, integers, okay? So this will be a plus 6i, okay? And then finally, we have 3 times 5, which is 15. Now, that's what we add together. So what really happens? We have 15 plus 26i. You just bring down the I. You're just adding it all up. Okay, in this case, you can think of I as, because it's not squared, you can think of it as it's just a variable that you're trying to deal with. Okay, now let's add the 8. But that 8 is 8i to the second power. Well, that is -1. Okay, so now we have something to work with. I see that we have 26i, and 8 times -1 is -8. Well, this is going to give 15 minus -8 is 7 plus 26i. Okay? All right, if you didn't see what I did, here, I'll come over here, sidebar, and this is what I had to do. I had to say the -8, let's see, we can say 15 plus the -8. No, that's not the best way to show you that. Let me write it across maybe, because it looks like I'm doing something totally different. We have 15 and then -8 and then plus the 26i. If you didn't see that, that's what I was doing. And we do have an option for that. Notice, other than maybe trying to deal with some large numbers to multiply, our calculator isn't super helpful because, again, I'll state there is no I, okay? And there's no way to manipulate the variables. It's just not a calculator of that level, okay? All right, so let's move on to number 2. Okay, this is addition. Okay, see how I use that traditional method? Here, we went from here to here. We use that traditional method of multiplication, the time honored, we all know it. Well, let's do that for addition. So I set it up, I say 5 minus 2i, and then I'll add that to 3 minus 4i. Okay, so that means, remember I'm adding, that's what I have, adding over here, not multiplying. So this will give me -6i and 8 in front. And that looks like it's option D, which is correct. Okay, let's go to number 3. Number 3, what is a simplified form for 2 plus 3i divided by 1 plus 2i? Okay, division with complex values is very different. In order to divide, we actually have to multiply. So this is what our illustration above is talking about. We're going to use the conjugate of whatever's given in our denominator. So this requires writing it correctly. Okay, so we have 2 plus 3i over 1 plus 2i. So we look at our denominator and we take the conjugate. What is the conjugate? Well, the exact same numbers. However, in like the given is 1 plus 2i. So the complex number, whatever given sign is before it, we use the opposite. So just like you have in your illustration. So this is what we have to do. But we have to do that over itself because essentially we're multiplying by 1. And any number over itself equals 1. So we have the conjugate. So that would be 1 minus 2i. And then you put that in the numerator also. So essentially we're taking the given, multiplying it by 1. But it will literally alter its state into something usable. Okay? So now be careful. This is where you need to use the rules of distribution. Now, I always like to look at the denominator first because there's something very useful going on, very clean. Well, if you look at the what you multiply inside, well, that would be 2i. And then the outside, oh, look there, -2i. Well, it becomes 0. So for the denominator, you don't have to look at everything, okay? If you do this correctly, what are we going to look at? Well, here, let me erase these here. Okay, so we will look at 1 times 1. You'll look at the first and the last. So 1 times 1 is 1, and plus 2i times negative 2i is negative 4i. Okay. Oops, not just 4i, 4i squared. Ooh, almost missed that. Now, it's not going to be so easy with your numerator. You have to go through it as a distribution. Okay. So that would be 2 times 1 is 2, and then 2 times negative 2i is negative 4i. Right, and I'm going to change colors. Let's do something else so we can see it. So then 3i times 1 is 3i. And then 3i times negative 2i, that's right here. Well, a negative and a positive, so that's going to be negative 6. But remember, we have I squared. Okay? All right. So we're not done by any stretch of the imagination. Okay? So we need to clean this up. That's the numerator and the denominator. They're just not cleaned up. So what do we have? We have 2. And then I see negative 4i plus 3i. Well, that's negative I. You could say negative 1i, but let's not bother with that. However, now let's look here at the 6i squared. That's negative 6. The I squared, as you remember, that becomes negative 1. That's much cleaner than what we had. Okay, then our denominator, well, that is 1 minus 4. And the I squared gives us negative 1. So at least we can quickly see the value of the denominator. Well, a negative times a negative is positive. That's a positive 4. Plus 1 is 5. Now, you could put it in the calculator if your numbers just get too wild, okay? You could, you know, take pieces of it, but you can't deal with that I. So you're just as well to try to do as much as you can, unfortunately. So yes, our denominator is 5. Let's see if we have something with a denominator of 5. Okay, we have A and we have C. So more than likely, B and D are not an option. We'll just go with it for now and see if something comes up. Okay, so now we have 2 negative I. Wait a second. That's the only I in the denominator. So we can bring him out. Now all we have to worry about is 2. And then we have minus 6 times minus 1. Well, that is a plus. So negative 6 times negative 1 is plus 6. So 2 plus 6 is 8. And actually, let's see. C is an appropriate value. Okay. Now, I'm not saying you can't use a calculator. Of course you could. It's just you can't use it in this state. But you can double check all your values as you go. Don't always trust yourself when you get tired, you're running out of time, you get frustrated on a test. So push some of the buttons, to help yourself out. For example, on that numerator, you could have just pulled the I out like I did. And then from there, you have the situation where you have 2 and then minus 6 and then the negative 1. And let's see what that gives us. There you go. That way you know at least the 8, the real number of our value, is correct. Now, we're pretty sure the complex, the negative I part, is correct. Well, we are. Our option's fine. Okay, let's look at number 4. Oh, great. We have some more. Well, luckily, they give us a little exercise, but essentially doing some of the same exact numbers of what we had above. I think they're trying to prove a point. It says, what is a simplified form of? And then they set it up for you. Notice the similarity. 2 plus 3i is your numerator. Well, that's what we had above. It's your denominator. They use 1 minus 2i instead of plus. Well, that's the same denominator. However, the question is, will this give us a different answer? The answer is yes. Don't just say, oh, I have the same answer and go with it. And if you look at your ABCD options, obviously that's not the case. Okay. So we will have the same denominator, I'm pretty sure. So let's write it out. 2 plus 3i over 1 minus 2i. Now we use the conjugate, which is 1 plus 2i. And then above it, you also have to have 1 plus 2i, because that should equal 1. Okay. Now, we know what to do with this denominator. That is 1 minus 4i to the second, I squared. Okay. And yes, we're going to end up with 5 in our denominator. Okay. All right, let's look at this numerator and deal with it. Well, 2 times 1 is 2. Okay. Here, we'll do 2 times 1 is 2. And then 2 times 2 is 4. And then I just hanging on for the ride. Okay. So that is plus 4i. Now we can already see a difference. Okay, there are some parallels, but the numerator will be different. Okay, so then we have 3i times 1. Well, that's just 3i. And then 3i times 2i is 6, but it's positive 6i squared. Okay, all right. So see how things are matching up in some cases. I mean, they're matching up as far as the values, but our positive and negatives are going to be different. Okay, so be careful when you do this. Okay, so that's plus 3i, and that's plus 6i squared. Okay, we can clean this up quite a bit. Well, the first thing we know is going to happen is the denominator is 1 plus 4 times negative. Oh, this is going to be very different because that's a negative 1. Oh, maybe it won't be 5 as a denominator. See, you have to be careful. It just isn't going to come out the same. Oh, I wrote it down wrong. That's still negative. Okay. Like I said, you got to be careful, and I wasn't being careful. Now we see it is going to be 5. Okay. So, caught myself writing things down incorrectly. Always got to do that. Okay, so let's move on. Let's get past me writing things down incorrectly. So I see plus 7i, and then I see plus 6, but we have an I squared, so that's negative 1. Okay, so the plus 7i, you can just write it down. You're done with it. So now you have 2 plus 6, and then the negative 1 in parentheses, that's negative 4. And that's where the difference shows up. Okay, not at all the same answer. Our denominator is the same, but our numerator, there was just no way that it could be the same. So let's go over here and see what we have. Well, C and D are out. Looks like B is appropriate because of the negative, negative 4. All right. Okay, let's move on to number 5. Number 5, what is the simplified form of 1 minus 2i over 3 plus I? Okay, again, use the conjugate in the denominator, okay? All right, so we have 1 minus 2i over 3 plus I. Okay, well, the conjugate is simply 3 minus I, and you have to use that above in the numerator, so that actually equals 1. Okay, and if you think about it, multiplying anything by 1 still gives an equivalent value because 1 times anything is the anything, but it gives you a shaken up form, something tangible, usable, easier to see in a different way. Okay, so we know that we don't have to worry about the inside and the outside, okay, in the denominator. I'm doing the denominator first. So 3 times 3 is 9, and negative plus I times negative I is negative I squared, okay? Now, it's a little different again with the numerator because you really have to carefully distribute. So we have 1 times 3 is 3, and then 1 times negative I is negative I, okay? And then negative 2i times 3 is negative 6i. Okay, and then we take that negative 2i times negative I. Well, a negative times a negative gives us a plus 2. But then, well, let's be consistent with the colors here. Okay, so we can see what we're doing. So let's get back to what I was doing. I was saying that's a plus 2, but the I is squared. Okay, so now we have something that we can clean up. Is something a little more usable. Let's look at that denominator. Well, I see 9 minus a minus 1. And I'm going to come down here and rewrite again. And that is negative times negative is a positive, and that gives me a 10. Okay. I can already see a couple things I can get rid of. Bam, bam. Now let's deal with the numerator. Okay. So I see a 3. Okay. However, negative, well, that's a negative 1 right there. So negative 1 plus negative 6, so that's negative 7i. Okay. However, let's see, we got the 3, we have plus 2, and then that's a negative 1. Okay. So just go ahead and bring down the negative 7i. Now let's deal with those other numbers, okay? So I know these are small numbers, but I still put them in the calculator just in case. During a test, I kind of went a little bonkers for a second, sugar drain or something. Okay, so let's push enter. You never know. So that is a 1. Is there anything that's going to match? Yes. Option D. Okay. And you see where we could have, the minute we saw the negative 7, we could see that A isn't going to be an option. Okay, let's look at number 6. All right. What is a simplified form of 5i to the third minus 4i plus I to the 20 plus 3i to the 26? Okay, here's the secret to this thing. It looks messy, but it isn't really that bad. If you kind of break down what I is, okay? So let's take a look at how I looked at it. Okay, first, this first one, I saw I squared times I, okay? And then 4i stays as is. Then I saw I squared. But how many of those are there? There are 10 of them. Laws of exponents can be used, okay? So plus 7. And then again, I saw I squared, but to the 13. Okay, now let's think about this. It'll work. Okay, I know that you probably weren't taught to do it this way, but if you break it down exponentially, it'll start to make a little more sense. Okay, so let's kind of rewrite here. We have 5 times -1 times an I. 4i stays as is. Now let's deal with this. This is plus -1 to the 10th power plus 7 -1 to the 13th power. Okay? All right, now we have something we can really use. Well, the first two values here are terms. Let's say terms. I see -5i minus 4i. Okay? Well, I'm going to go ahead and break those down. That's -9i, or condense them. Okay, there we go. Well, -9i, well, that's several options. I don't know how helpful that was. At least we got rid of one option, okay? All right, now let's look at this. Well, what is -1 to the 10th power? Let's see what that is. Okay, parentheses, -1. Let's go carry it up to the 10. It's just 1. So, plus 1. Now, let's look at the next part. Now, be careful. 7 needs to be multiplied to whatever happens after it, meaning deal with the -I to the 13th power first, and then multiply it to the 7. Don't try to multiply 7 times -1. That is an invalid operation as far as order of operations, okay? All right, so let's do the same thing. We could even arrow up, highlight, grab this other -1, enter to bring it down, type over, go over, arrow over, then put in a 3, push enter, -1. Okay? And then what do we really have? We have 1, I'm going to bring all this down, 1 minus 7. 7 times -1 makes that -7. So I see -6. Now we have something usable, or rather, we see an option that we can select. Okay. Now it's written differently. -6 minus 6i. They just switch the position, because the way we have it is not in a standard form for complex numbers. It's the real part, then the imaginary part. Okay, or let's say the complex part. Okay, so A and B didn't satisfy. A had the wrong values and B had the wrong sign. All right, so let's look at number 7. Okay, what is a simplified form? Oh, this isn't too bad. -7 plus 8i minus, in parentheses, minus 5i plus 4i to the second power. Well, boy, we can clean up this right here. First, let's rewrite this. This is -5i plus 4 to the -1. Okay? And that will be, need another parentheses. So that'll be -4. So what do we really have? We have -4 minus 5i. Okay. So then that needs to be subtracted from our first uh, two terms in parentheses, our first set in parentheses. Okay. Regardless, we've rewritten it. So let's add it together. All right. So what do we do? Well, just write it like this. This is how I handle it. I stack them, okay? So -7 plus 8i minus -4 minus 5i, okay? Right, well, that's really we can do it one at a time, but really what we need to do is that subtraction needs to be distributed. I'm going to change colors. So a negative times a negative becomes a positive here, and a negative times a negative becomes a positive. So honestly, we're adding, okay? Because we rewrote and we have to distribute, as well as this becoming -1. It just kind of changed the whole form. Okay, let's look at what we have. This is plus 13i, and -7 plus 4 is -3. And looks like we do have a valid option, which is C. Okay, this is the last question in this video. Thank you for watching and sharing and liking. I know that I say that at the end of every video because it is truly and honestly appreciated. And subscribers, you've really helped continue, to give that support so we can continue to bring you free videos. All right, thank you for watching. Happy testing.